All right, so finishing up this example, we just found out that the clown was in the air for 4.5 seconds, and that's what answered question A. Question B, how far from the base of the cliff will he land? So we want to know this distance right here. That distance is our horizontal displacement. Now remember I said time is universal. So 4.5 seconds of hang time, or 4.5 seconds of travel time through the air, means that's how far or how long he was able to travel horizontally. Using our formula for uniform motion, delta D equals VT. We can calculate our missing value by doing 40 multiplied by 4.5. We get 180 meters. So 180 meters. So therefore, the clown will land 180 meters away from the base. Oops. So with these questions, with projectile motion questions, most people, the common error is the signing, or the signs. So you have to be very, very careful with down and deciding what is going to be your direction of positive value. So you can switch it and say down is positive. It will get you the same amount of marks, but you just have to be careful because that really determines how the signs get entered in, or what signs get entered into your equation. So please keep that in mind. Okay. Now, circus clown is shot at 30 meters per second horizontally, 15 vertically out of the cannon. So it's basically the same question, except now we have a vertical velocity. So same idea, clown in the air. So here he goes. But now he was shot upward, so now he's going to have an arc or a parabola. So we break it apart. Same process every time. As soon as you see projectile motion, you know you're breaking this into horizontal and vertical. All right, so I break it apart. What's my information? Clown shot at 30 meters per second horizontally. So my horizontal velocity is 30 meters per second, and I'm going to say to the right, based on my diagram, 15 meters per second vertically up. So 15 meters per second up. The cliff again is 100 meters high, so that's a vertical displacement. So delta D is 100 meters, I guess, down to be consistent. Okay. So we want to answer the following. Well, what other information do I know? I know gravity or acceleration is 9.81. It's not going to be listed in a question. So very important that you write that down or remember that it's part of the given information. How long is the clown in the air? Well, it's the same question as we just did. The difference is your vertical velocity is not zero. So how does that influence or affect our answer that we just finished? Well, we already know the formula we're going to pick. Delta D equals, so I guess this is part A, V1 delta T plus 1/2 A delta T squared. So we're looking for time. So negative 100 equals 15. It's positive because I'm going with my typical sign convention. Up and to the right is positive. Delta T plus 1/2. Gravity is down, so it's a negative. Delta T squared. Now I have delta T's everywhere in my equation. So, not an overly happy camper at the moment. So I'm going to do what I can to simplify this. I'm going to bring everything to the same side. And I'm going to bring the delta T squared, everything to the left side. So that would become half of 9.81 is 4.9. Oops. And it's 4.91 delta T squared minus 15 delta T minus 100 equals 0. So how do we solve this equation? This is why people think physics is tough, because there's going to be some people right now that are screaming at their monitor saying, no, it's not true. The only way you can solve this is by using the quadratic formula. Yes, indeed. this is a quadratic or equation of a parabola. So you can go through and you can solve it by factoring, but as soon as I see decimals, I don't bother making the attempt. So I am going to use the quadratic formula, and I know again I can hear the shrieks all the way from where I am, even back in time. So using the quadratic formula to solve for t, negative 100. That's all divided by 2 times 4.91. I would get 15 plus or minus 46.8 over 9.81, which means I'm going to end up with two solutions. So 15 plus the 46.8 divided by 9.81, and I get 6.3 seconds, or 15 minus the 46.8 divided by 9.81 equals negative 3.2 seconds. At this point, you're going to say, can't go back in time, even though it'd be really cool, but this is what we call inadmissible. Okay, in this course, I do not want to see negative times. Inadmissible is the correct terminology. So therefore, the clown was in the air for 6.3 seconds. So giving him a vertical velocity increased his flight time. All right, so that means that delta t over here will also be 6.3 seconds. So B part, how far away from the base of the cliff will he land? All that's really changed for us is that time. So delta D equals V1 delta T. So we're looking for that. So we have 30 multiplied by 6.3. Calculating that, 30 times the 6.3. And we get 189 meters. So therefore, he will land 189 meters to the right. There we go. So there's a projectile motion question with a vertical velocity. Now I believe I have a final example here. So a sharpshooter fires a bullet horizontally at 100 meters per second. At the same time the bullet is shot, the empty shell casing is ejected. The empty shell case landed on the ground with a velocity of 5 meters per second down. How far did the bullet travel? So, big thing here that you need to remember is that if you have two bullets, I'm going to make square bullets, the one that's dropped to the ground will land at the same time as the one that's fired horizontally. All objects fall at the same rate, even ones that are being projected or thrown. So, if they're from the same height and the empty shell casing is ejected, we're assuming that it's ejected basically down with no velocity. We end up with this situation. So you can still break this down, okay, into your horizontal and your vertical. Just a matter of decoding the information, and yeah, you have a little bit different information this time. So what do we know? We know that the bullet is fired horizontally, so velocity horizontal is 100 meters per second, and based on my drawing, it's going to the right. At the same time the bullet is shot, the casing is ejected, the empty shell case lands on the ground. So it landed on the ground, so that means its final velocity was 5 meters per second. Now, on a test, you can ask to clarify, but I would say the initial velocity was 0 meters per second, that was the intent. But if you're not sure, this is a case where, I mean, it never hurts to ask, and if there is the information's there, I just say everything's there. But in this case, I would clarify it was 0 meters per second initially. What else are we given? That's it. We know no other information. So there's the unspoken information, acceleration due to gravity. It's 9.81 meters per second squared, and that's down. And we want to know how far the bullet traveled. So that means that we are looking for the horizontal displacement, which means that we need to know a time. So time would be really good to get, and that's what we're going to look at here. So time is the unknown. So again, you decode the information like you did the other day with the previous work. V2, V1, and A with delta t, and you find that you have this equation, V2 equals V1 plus A delta t. Substituting in your information, and remember, I'm assuming up is positive with mine. You're more than welcome to pick your own, just be consistent. So V2 is down, so I'll have negative 5 equals, V1 was 0. Acceleration's negative. I'm looking for delta t. So now I just got to do the division here. So divide both sides by negative 9.81. And we find that 5 divided by 9.81 is 0.51. So delta t is 0.51 seconds. So now we have our delta t over here. That means we can solve this question. So the bullet that was fired will travel 100 times 0.51, which would give us 51 meters. Okay, and that's to the right. And remember, 100 meters per second is a fairly low muzzle velocity. So, and the gun, they must have been fairly low to the ground because half a second is not too much flight time. So therefore, the bullet travels 51 meters to the right. Okay. So the projectile motion homework is shown below. There's not a ton of questions there, but they can be a little bit challenging, and most of the time, like I said, it's going to be sign errors if people make mistakes. So if you do have a number that you can't take the square root of, or it seems backwards, check your signs first. Make sure you have someone fresh eyes take a look at it. If you're really having trouble with this homework, make sure you let me know, and we can sit down and go through it stage by stage.